So if you're working in a research lab, you already know this, right? Technical skills, they're not just nice to haves anymore. They are totally essential. But what if you're starting from scratch? Like absolute zero? Well, we're about to break down a path that's designed to turn pretty much any student into the lab's go-to tech hero. And this quote, man, it really gets to the heart of it. Look, modern research is all about data, and that data has to move through some pretty complex systems. So labs don't just need people who can follow a recipe, they need real problem solvers who can figure out what's wrong when those technical glitches pop up and, stop a whole project dead in its tracks.
And yeah, that's the million-dollar question, isn't it? I mean, you're already buried in your actual science, right? So how in the world do you find the time and the right place to even start to build this whole new skill set without just feeling completely underwater?
Well, here's the answer. There's this course, Computing for the Research Lab, and it's built on a really simple but honestly powerful idea. It assumes you know nothing. Seriously, it's designed to be this friendly, super accessible way in, no matter what your background is. Of course, for any journey like this, you need a great guide, right? And your instructor here is Dr. Diane Patterson. And her own story is actually the perfect example of how totally different fields of knowledge can come together in some really amazing ways. Just check out this journey. It starts in philosophy and English, then goes through linguistics, into a psychology PhD, even includes research with Alex the parrot, the famous one, and then lands in neuroimaging. I mean, come on, that is the perfect proof that you do not need a computer science degree to master these tools. You just need the right map to get there. So what's actually in this new toolkit you're going to build? The course basically organizes your skills into 3 main chunks. We're going to start with the basics and get you all the way to a full modern research workflow. First things first, you've got to build that foundation. And this isn't just boring theory. It's practical, hands-on knowledge of what's actually inside the box. You know, the CPU, RAM, GPUs, and how networks really work. It's all about learning the language of the machine so you can start to figure out problems on your own. Okay, next up, you step into the command center. Seriously, this is where you stop just clicking on things and really become a power user. You're going to learn the Unix command line, which is the backbone for most scientific software out there, and get your hands dirty with programming essentials like Bash and Python. And finally, you'll put it all together by mastering the modern workflow. This is the stuff that makes research solid and reproducible. You'll learn how to organize your data, how to use version control like Git to track every change. It's like a time machine for your code. And how to package your software with tools like Docker. It's like putting your entire project in a neat little box so that anyone, anywhere can run it perfectly, every single time. Okay, this slide right here, it is the perfect example of the change we're talking about. Look at these 2 reports. The one on the left, that's just a vague help me. The one on the right, though, that's a professional diagnosis. It gives context, the exact command that was used, and the specific error message. That is the level of clarity you're going to have. It's a total game changer. All right, that sounds like a lot to learn, I get it. So how is it all structured? Well, the whole thing is really designed from the ground up to be super manageable and flexible, especially for busy students like you. So let's break down the logistics. The course is fully asynchronous, which means you can fit it around your lab schedule and your other classes. The workload is a totally doable 6 to 8 hours a week, and it's all packed into a focused 7.5-week session. And maybe the best part, no hidden costs, no expensive textbooks or software. Everything you need is already included. And you gotta check out the grading philosophy here because it's really important. See that huge 85%? That comes from the weekly modules. This course isn't about cramming for some big, scary final exam. No, this is all about rewarding that consistent, steady effort you put in each week as you build these skills piece by piece. So where does all this lead? Well, it all comes together in one final capstone project. This is where you get to pull together everything you've learned and really prove to yourself just how far you've come. And this project, it's not just another assignment. It's basically a simulation of real-world research. Think about it like this. Your supervisor hands you a new piece of software. Your job? Figure it out, document how you did it, and report back. The whole point is to build that confidence you need to be a truly independent problem solver in the lab. The project itself is broken down into these really clear, manageable steps. First, you pick a tool you're actually curious about and write up a proposal. Then you just dive in. You document your real experience learning it, the wins, the struggles, all of it. From there, you analyze those challenges, and finally, you evaluate the tool like a pro.
It's a complete cycle that's exactly what you do in a real lab. And that's really the big payoff, right? By the end, you're not the one asking for help with computer stuff anymore. You're the one solving the problems. You'll be confident with the technology, way more productive, and super organized. You'll be a true asset to your team. But in the end, this is about way more than just learning a few skills. Once you have this amazing toolkit and you know you can tackle pretty much any computational challenge that comes your way, the real question is, what problem are you going to solve first?